Hello, today we are going to be talking about problem solving on momentum. In the last class we were able to talk about momentum, we were able to define momentum, we were able to distinguish between the types of collision, that is the elastic collision and the inelastic collision. I hope you can still remember, and if you can't, you can please do watch the previous video. However, I will still do a previous knowledge on the last video. Okay, now elastic collision, okay, is simply the collision of two bodies, okay, in which they move at what different velocity. In this kind of collision, the elastic collision, in this kind of collision, that's the elastic, pardon me, let me use this part, elastic collision, the KE is conserved, the momentum is conserved. KE is conserved, the momentum is conserved. Okay, the inelastic collision, on the other hand, after collision, the two bodies move together with the same velocity. Okay, here the inelastic collision, on the other hand, the momentum is conserved, but the kinetic energy is not conserved. And I've told you in the last video, the reason for this is because of what? Some of the energy is lost in the form of heat and sound. Okay, so today we are going to be solving problems on momentum. We were able to solve a problem, okay, an example in the last class. Today we are going to continue with problem solving on momentum. Okay, now we have this question on the board. We have this question on the board to be solved. Okay, solution. So we'll quickly draft out the parameters from the question and then we solve. Okay, now it says two balls of masses 0.5 and 0.3 kg. Okay, two balls. Let's say these are the two balls. One ball. Okay, let me bring it a little bit up. Solution. This is the first ball. This is the second ball. Are you following? Of mass is 0.5 and 0.3. Okay, so let's say this one is of mass 0.5 kg, and the second one is what? This is 0.3 kg. Okay, move towards each other in the same line. Okay, they move towards each other. It means the arrow is going to be this way. If they are moving towards each other, it's going to be this way. Can you see it? Okay, they are moving towards each other. So, at the speed of 3 meters per second and 4 meters per second, respectively, like I said before, the first figure is for the first ball, while the second figure is for the second ball. So we have the 3 meters per second. This is for the first, and then we have 4 meters per second for the second. 4 meters per second. Okay? After the collision, the first ball has a speed. So this is before collision. So after collision, okay, it says that after collision, the first ball has a speed of 1 meter. This is the first ball. Let's call this one ball A, and let's call this one ball B. So you see the first ball has a speed of 1 meter per second. So this, let's say this is after collision, this is the first ball with a speed of 1 meter per second. Okay, in the opposite direction. Oh, I even drew the direction before. Okay, in the opposite direction. Let's assume that after collision, the body is expected to move in this direction. Okay, so if it's in the opposite direction, it means our direction will be this way. So we have 1 meter per second. Okay, in the opposite direction. What is the speed of the second ball? What is the speed of the second ball? So, like I said before, if the direction is this way originally, it is expected that the body should move this way after collision. So, we will maintain this direction while this maintains this, okay? In the opposite direction, what is the speed of the second ball after collision? So, we don't know this. This is what we are looking for, okay? See body A, body B. This is 0.5, and while this one is 0.3 kg. The masses doesn't change after collision. Okay, So now we have this information, we can solve. We are looking for this. So permit me to wipe the board. So I will draw this again up. So we have this, since we already have the information in diagrammatically, we have the information, we can solve. This is before pollution. I'm only transferring this information here, so you can see it clearly. So we have 0.5 kg, we have 0.3 kg, this is 3 meters per second, and this is 4 meters per second for before pollution. I think I've been able to transfer all information. Then the next one, after pollution, we have this, and then we have this. Okay, V, and then we have this 1 meter per second. Then body A, body B. This is 0.5 kg. This is 0.3 kg. Yeah. Okay. Now we have transferred the information up. I can wipe so we can solve comfortably. We can solve comfortably now. Now the formula is still the same thing. Okay. Mu plus mu is equal to mu plus mu. But however, I've told you before that the negative will always represent opposite direction. Plus, with this information, we are going to put it into this while we're solving. Okay. Now we have mu. If you don't like mu, you can use v. Okay. V1 plus M1 V. M2 V2. I'm still trying to make the mistake I made in the last video, swapping V1 for V2. It's a very serious mistake. Please try as much as you can not to make those mistakes. So we have this M. If this 1 or 2 we confuse, I think it's better we use this A. M A V A. N B V B is equal to what? N A V A plus what? M B V B. Now let's do this. Remember the question says, even from the arrow you see that they are opposite direction. So we take note of the sign. This is going to be what? A minus. This is going to be what? Minus. Okay. Now this one is moving in the opposite direction. So the velocity is going to be what? Minus. Are you here? Are you following me? So now let's substitute into the formula. Now we have our formula. Okay, the formula is the same. Before collision is equal to after collision. Momentum before collision is equal to momentum after collision. But you have to take note, when you have opposite direction, you always put a negative sign. Take note, you put a negative sign. So now let's put our parameters. MA, we have 0.5 times what? 3 minus 0.3 times 4 is equal to minus 0.5 times 1 plus 0.3 times V. So 0.5 times 3 will give us what? It will give us 0.15 minus 0.12 is equal to minus times this will give us minus 0.5 plus 0.3V. 0.3V. So we'll collect like terms. Okay, this one will come here. This one will come here and be a positive. So we have 0.15. No, think 0.5 times 3. 3 times 5 will give us 15. 3 times this 0, then 1.5. Sorry. Please, sorry. I mean, nobody is above mistake. Nobody is above mistake. So we have here, this is going to be 1.5. 0.5 times 3 is 1.5 minus 0.3 times 4 is 1.2 is equal to minus 0.5 plus 0.3v. Let's collect like terms. So we have 1.5 minus 1.2. You bring this one here, it becomes positive. We have plus 0.5 is equal to 0.3v. So let's sum. Let's sum this. Please, I'm going to use the easy way out. So 1.5, this is positive, plus 0.5 will give me what? 5 plus 5 will give me what? 10. Right? Write 0, carry 1. Add it to this will give me 2.0. Is that it? Then 2.0 minus 1.2. 2.0 minus 1.2. You borrow 1 here, you have 10 minus 2, we have 8. 2 minus 1. No, we've borrowed 1 already. 1 minus 1, we have 0.8. So, everything here gives us 0.8 is equal to 0.3v. What is our v? We divide both sides by 0.3 to have v. So we have v is equal to 0.8 divided by 0.3. This is equal to, how many times can 3 go into 8? 2. So we have 2.66. So approximately we have 2.67. 2.67, yeah. But the unit of velocity is meter per second. So we are going to write this in what? Meter per second. Now let's go to our second example. The second example goes this way. A ball P of mass 0.25 kg loses 1/3 of its velocity when it makes a head-on collision with an identical ball Q at rest. After the collision, Q moves off with a speed of 2 meters per second in the original direction of P. Calculate the initial velocity of P. Now let's do this. Okay, usually you represent this information diagrammatically before solving. So now a ball P. Let the ball P be this. For the first time, we're not going to be using A and B. So all this while you're not doing anything.
I'm doing them. See. This is recording. You want to calculate them?
Are you set? God, David.